We're on 3.2. Why does it say 0.1? I don't know. Mistakes are made everywhere, but that's okay, I'm human. We are solving systems using something called elimination. We know how to graph and solve by graphing. We know how to graph or do it by using something called substitution. I already taught you that in 3.1. But now, what if those are a pain in the ticker to solve using those methods? I need to give you a different tool, a different thing to use, and that thing is elimination. So by the end of this, you should be able to solve systems of linear equations in two variables, just like before, using the elimination method. Okay, let's just get right at it. Okay, solving a system using this method. Step 1 is to blank one or both equations so the variable has the same coefficient. It's multiply. We want to multiply one or both equations so the variables have the same coefficient. So this is what I mean by that. You're going to pick one variable, the x's or the y's, and you want to make them the same. So you're going to multiply these equations by something to make them the same. I'm going to choose the x's. Could you choose y's? Sure. But I'm going to choose the x's and focus on those. I need to get the least common multiple for 3 and 5, and that's 15 in this situation. So I'm going to multiply this top equation. To get this 3x to be 15, I'm going to multiply it by 5. And the bottom one, I'm going to multiply this one by 3 to make that 5x 15. So by 3. Step 1 done. Okay, we got to multiply them. Let's just rewrite it down here now that we multiply them. 5 times 4 is 20. 5 times 5y is 25y. And 5 times 3x is 15x. Okay? And then the bottom one, when I multiply this in there, I got 3 times 6, which is 18. I got 3 times 7, which is 21y. And I got 3 times 5x, which is 15x. Notice these are the same now. That was our goal. Okay? Now, step 2 is to blank or blank the two equations to eliminate a variable. Well, what we really want to do is we want to add or subtract the two equations to eliminate a variable at this point. So let's take what we have right here. We're going to take these two equations that we just wrote. This one right there, that one right there. Actually, we'll move them up a little high. Doesn't matter the order they're in. And we're going to add or subtract these two, so one of the variables goes away. Well, we're focusing on the x's. So let's focus on those still. Let's not change this up. How can I eliminate 15x and 15x? If I added these two, would they go away? Well, no. If I added these two, it would be 30x. What we need to do is subtract these two, because 15 minus 15 is nothing, right? So let's subtract these two equations. I got 15x minus 15x, which is no x's. I don't have to put that there, but I'm just going to kind of point that out. Now, 25y minus 21y is 4y's, right? 25 minus 21, 4. And lastly, 20 minus 18 is 2. So now I got rid of this x. Really, I have just 4y is equal to 2. Okay? So we just did it. We did the subtraction or the addition part. Step 3 is the solving part. Now we just solve for the remaining variable. Okay? Oh, have we done that? Yeah, we've got to solve. So we got to figure out what this y is. Oh, that's a pretty easy process. Let's just divide both sides by 4. Divide both sides by 4. And we get y is equal to 2 over 4. And we all know that that is 1 over 2, 1/2. 2/4 of a pizza is the same as a half of a pizza. So that's what our y is. Solve for the remaining variable. I'm sorry, I didn't put that in there initially. So we know y is 1/2, and so let's just take that 1/2 and put it in where it's supposed to be. 1/2 down there. We just took that and plugged it in down here. Okay. Now that we have the 1/2 there, our next goal, our step 4, is plug the value into either equation, either equation, and solve for the other variable. So now let's just do that. Let's plug this in for any of these two equations. I like to plug it into the initial equation, or one of these initial equations, just in case I made a mistake at the beginning. So I'm going to take this 1/2 right here. Let's make it this green 1/2. And I'm going to plug it into this y right here in this equation. So I'm just choosing the equation. It doesn't matter. So I'm going to rewrite the equation. Too bad it's not solved for y, but that's just is how it is. So I got 3x plus 5 times the 1/2, because I'm going to put this 1/2 into this y right here. 5 times 1/2, and that is equal to 4. right there. Okay, and now we're just going to solve for the x. So I got 3x plus 2.5 is equal to 4. Let's subtract 2.5 from both sides just for fun. And so I got 3x is equal to 4 minus 2.5. Oh, that's 1.5, right? And then we're going to divide both sides by 3. And so I have x is equal to 1.5 over 3. Well, how many times does $1.50 go into $3? It goes in 2 times. So this is the same as 1/2. And so I'm going to take that and plug that in for my x spot. 1/2, 1/2. So the solution to this system equations is 1/2, 1/2. And so if you think about it graphically, going back graphically, if I had these two graphs, and this is one and this is one, they'd be crossing right here. So I don't know what the graphs look like. I'm just guesstimating, but this is where they cross. Right at 1/2, 1/2. And that is how you use elimination to solve systems of equations.